Welcome to section 2.3, Biconditionals. Alright, and here's your math joke. Which state has the most math teachers? If you think it is Massachusetts, you would be right. Okay, so before we start talking about biconditionals, let's review these four statements. If you can remember, conditional statements are if P, then Q. In symbol notation, or symbolic notation, that would look like this. P implies Q. The converse is going to be when you switch P and Q. If Q, then P. Again, in symbolic notation, Q implies P. Inverse. That one is going to be if we negate the conditional. So if not P, then not Q. So symbolic notation, not P, implies not Q. And the contrapositive. We then just need to switch the inverse. So if not Q, then not P. Okay, so hopefully you now know those four statements like the back of your hand. We're going to use those four to write a biconditional statement. And a biconditional statement is a statement that is formed by joining the conditional with the converse. So to do this, we drop the if and then parts, and we join the hypothesis with the conclusion by using the phrase if and only if. Now, for a biconditional statement to be true, then both the conditional and the converse need to be true. Alright, let's practice with example 1. It says for the conditional statement below, we want to write the converse, and then we're going to write the biconditional. So the conditional is if x equals 2, then x plus 3 equals 5. So what I've underlined the first time, that's my hypothesis. And the second part is my conclusion. So for the converse, I just need to switch them. If x plus 3 equals 5, then x must equal 2. Okay, now the new part is the biconditional. Simply, you just join the hypothesis, x equals 2, with the conclusion by using the phrase if and only if. X plus 3. So my biconditional statement is going to be x equals 2 if and only if x plus 3 equals 5. That is a statement that you can read forwards and backwards. If x plus 3 equals 5, then x must be 2. The backwards way is obviously the converse. Okay, let's try example 2. Now this one, they're giving us a biconditional, and from the biconditional we need to write the forwards way, which is the conditional, and the backwards way, which is the converse. So what I'm going to do is I'm going to underline my hypothesis and then underline my conclusion 2 times. All right, a solution is neutral if and only if its pH is 6. So there's that phrase again, if and only if. And that phrase is separating the conditional or the hypothesis from the conclusion. So this is my hypothesis, and this is my conclusion. So my conditional statement would be, if a solution is neutral, then its pH is 7. All right? To write the converse, I just need to switch my hypothesis with my conclusion. So if its pH is 7, then the solution is neutral. I want you to do the next example on your own. And when you get to school, let me know if you have any questions about it, and we'll go over that. Okay, when we first started talking about biconditionals, we said a biconditional statement, in order for the biconditional to be true, the conditional statement had to be true and the converse had to be true. Well, when they are both true, that is when you have a definition. So the definition of definition is when the conditional and converse statements are true. So all definitions can be written as true biconditional statements. You could take a definition from biology, and it can be written as a biconditional. You could take one from American history, it's going to be written as a biconditional. Okay, those would all be true. Example 3, we're going to write this definition as a biconditional statement. A pentagon is a closed 5-sided figure. That's a definition of a pentagon. So how do I break it up? You got to think, what is a conditional statement for this, and what would the converse be? So I'm going to say, and here's just one example. A polygon is a pentagon. And how do we join the conclusion and the hypothesis together? With the phrase if and only if. It has 5 sides. So there is my definition as a biconditional statement. A polygon is a pentagon if and only if it has 5 sides. Okay, that's going to conclude our notes for today. Again, if you have questions on this material, let me know, please.